Number 12, graph the function rule. So we're going to make a table of values to find points to graph. So let's do that. So first, I'll make a t-chart with x and y, and I choose a couple small numbers to represent x. I'll choose 0 and 1. Now I'll substitute both of those in for x. 2 times 0 is 0 plus 1 is 1. 1 times 2 is 2 plus 1 is 3. So I'm going to graph the points 0, 1, and 1, 3. Click to enlarge the graph, choose a line. Now 0, 1, click it, and then drag over the 1 and go up 3. Press save, check answer, and that's your graph for number 12. To 17, graph the function rule. Tell whether the graph is continuous or discrete. The height h in inches of the juice in the 20-ounce bottle depends on the amount of juice J in ounces that you drink. This situation is represented by the function rule h equals 8 minus 0.4 J. So we need to create a table of values to find a couple coordinates to graph. So let's do that. So I make a t-chart with x's and y's. Now my goal is to have y values that give me a whole number value. If they aren't, it will be hard to graph. You can use your calculator to find a table of values as well. So I'm going to substitute these numbers in for j because j represents x and h represents y. So 0 times 0.4 gives me 0, so 8 minus 0 is 8. Do the same thing for the rest of your values, substituting them in for j, and I'll get 7.6, 7.2, 6.8, 6.4, and 6. So my 2 points I will graph is 0, 8, and 5, 6. So let's do that. Click to enlarge the graph. Click line. Go to 0, 8, and then 5, 6. Click save. Check answer. Now the graph should be either continuous or discrete. Now since we're dealing with juice, we can have an amount of juice being, say, like 0.2 ounces, 0.3 ounces, and so on. It isn't limited to whole number values. That means it is continuous. Now, if my situation involves something that could only be a whole number, then it will be discrete. So this will be continuous. And that's number 17. Number 18, we're graphing the function rule. When we have absolute value bars, it means it is absolute value function. Its graph looks like a V, so that means it's not going to be A or D. It will either be B or C. Minus 1 on the outside means we're shifting it down, whereas C, you're flipping it upside down, so that means the answer will be B. For number 19, we're graphing this rule. A function with x to the third will be a cubic function, which means it will not be b. That's a parabola. That's an x squared function. So plus 2 on the outside means you're shifting it up 2. That means it'll have to be c. D, we're shifting it down. A, you're shifting it to the left. So your answer is going to be C for number 19. Number 20, it is an x squared function. So that means it is going to be a quadratic, negative in the front. So it's going to be flipped upside down. So that tells me it has to be A. Everything else is either flipped up like D, or in terms of B and C, it's not even a parabola. It's an absolute value function. So your answer is going to be A. That's number 20. Number 21. The amount a basketball coach spends at a sporting goods store depends on the number of basketballs the coach buys. The situation is represented by the function rule A equals 17b. So for A, we first got to make a table of values and graph the function rule and determine if it's continuous or discrete. So let's make our table of values. So basically all we got to do is B represents X, A is Y. We just multiply each of these numbers by 17. So 0 times 17 is 0, 1 times 17 is 17, 2 times 17 is 34, 3 times 17 is 51, and 4 times 17 is 68. So that's our table of values. Let's go back and type it in. So we're typing in 0, 17, 34, 51, and 68. Now our graph is going to be increasing, so that tells me it can't be A or D. Now the difference between B and C is that one is continuous and the other is not. The line going through it means it could be a point in between the whole number points. Now the situation involves us buying basketballs. We can't have 0.5 of a basketball. You can only have whole number basketballs. So that means our choice is going to be B because that represents whole number coordinates. So B is going to be the graph. So is the graph continuous or discrete? We just got done saying it's discrete, and that's because only whole number values will work or have meaning. So the answer is going to be C. Now, we got to figure out how many basketballs she bought after spending $102. So let's figure that out. So to figure out how many basketballs she bought after spending $102, we got to substitute that 102 in for A, which is the cost, and solve for B. So we divide both sides by 17, and we get the number of basketballs is 6. So let's type that in. Bring that in. That is the answer for number 21. Number 22. Write a function rule to represent the situation. The amount Y of your friend's allowance if the amount she receives is $10 more than the amount X you receive. So you have the amount Y, that's our total. So Y equals $10 more than X. So that'll be X plus 10. And that's the answer for 22. Going to 25. Write a function rule for the area of a rectangle whose length is 5 feet more than its width. What is the area of the rectangle when its width is 9 feet? So let's take a closer look at that. So first, the area of a rectangle is length times width. We're told that the length is 5 feet more than its width. So you got to turn that into an equation. So length is going to be L, is in math means equals. So L equals 5 feet more than its width. More than will be plus, so it will be L equals the width W plus 5. So now we got to substitute W plus 5 in for L because it equals L. So we have A equals, take L and replace it with W plus 5 times W. Distribute the W, we get W squared plus 5W. So that's the function rule. So let's type that in. So we type in W squared plus 5W. Now we need to find the area when its width is 9 feet. So we basically got to substitute in 9 for W. So let's do that. So take out W, replace it with 9. 9 squared is 81. 5 times 9 is 45. Add 81 and 45 up, you get 126. So the area is 126 feet squared. So let's type that in. So typing it in, we have 126. And that's the answer for 25. Number 26. Use a mapping diagram to determine whether the relation is a function. So, first, which of the following mapping diagrams represents the situation? Now remember, domains the x values, range is the y values, and you only write each number once. If there's more than one number that's the same, only write it once. Like, look at my domain. We have 2 x's with 5's, only write 5 once. And since domain is 5, that is going to be x. That should be on the left then. That means either C or B. B writes the x twice. We don't have that. We only write it once. So the diagram that represents my relation is going to be C. So is it a function? For it to be a function, my domain, each number can only go to one number in the range. Here, both 2 and 5 go to two different range values, so it's not going to be a function. Number 27. What is f of 2 for the function f of x equals 4x plus 1? All you do is substitute 2 in for x. So 4 times 2 is 8, plus 1 is 9. And that's number 27. Going to 29. Use the vertical line test to determine whether each relation is also a function. So if you draw a vertical line through the graph at any point, if it goes through the graph only once, then it is a function. If it intersects the graph more than once, then it is not a function. Vertical line test only goes through only once on this one, so it is a function. So you're going to choose yes. To number 31, sound travels about 340 meters per second. The function d of t equals 340t gives the distance d of t in meters that sound travels in t seconds. How far does sound travel in 32 seconds? So all you do is substitute in 32 in for t, because 32 is time. So let's do that. So substitute in 32 in for t. 340 times 32 will give me 10,880. So let's put that in. So type in 10,880. That's the answer for number 31. Find the range of the function for the given domain. So all we need to do is domain is x, substitute each of these values in for x, and see what we get for y. So let's do that. So I make my table of values, or you can use the graphing calculator to find your table. So I substitute in -2 in for x. 3 times -2 is -6, minus 8 is -14. So that goes here. Doing the same thing for the rest of them, give me -11, -8, -5, and -2. So let's choose our answer that includes them. Looking at our choices, our answer is going to be B. That's number 32. Number 33. Find a reasonable domain in range for the function, then graph the function. A car can travel 33 miles for each gallon of gasoline. The function d of x equals 33x represents the distance d of x in miles that the car can travel with x gallons of gasoline. The car's fuel tank holds 11 gallons. So domain is going to be x for gallons, and the amount of gas in the tank at any given time will be between no gas and 11 at the most when it's full. So between 0 and 11 will be the amount of gas, or our domain. Choose the correct range. So what we do is we substitute in 11 in for x and 0 in for x, and see the largest amount of distance we can get with those miles. So 0 times 33 is obviously 0, and 11 times 33 would be 363, so it's going to be between 0 and 363 for the distance for the range. Now the graph, we start at 0, 0, so we know it can't be B, and we know our highest point has to be 363. C goes on forever, so it can't be C. So it has to be either A or D. Now halfway between 0 and 600 is the 300. For D, this point is below 300, and we know our range goes above that, so our answer has to be A. And that's the answer for number 33.